allowed me to calculate the internal volume of bombs of this type and then scale it up with the varying sizes of the bombs. It also allowed me to calculate the ratio of gunpowder to the volume of the bomb to ensure that I was staying true to the construction of this type of explosive. So after doing all of that scaling to match the size of the micro bomb, we see that the shell would be filled with 20.5 pounds of explosive powder, 9.32 kilograms. Now, in reality, the actual explosive force of a bomb would vary based on a ton of variables. I went through a ton of formulas.
So many formulas.
Looking at the tensile strength of iron, which is how much tension it can withstand without breaking, burst pressure of the bomb, heat capacity ratios for the gases within the bomb, the Rhodes method of determining the energy of an explosion, and it was boring. It was pretty dull.
You think that studying the science of a bomb would be a little bit more explosive?
Nope, just a whole lot of math, and it was pretty dull when it was written out in script form. So instead, it's just a lot simpler to say this. On average, black powder contains about 3 megajoules of energy per kilogram of powder, which isn't actually all that much when you look at it. That's about the same amount of energy present in a candy bar. Wood contains over 6 times that much energy per kilogram than gunpowder. The difference is, though, that gunpowder releases all that energy pretty much instantaneously, whereas burning a lump of wood takes a whole heck of a lot longer. But with those numbers, we can translate that to the micro bomb producing 28 megajoules of energy or 6.7 kilograms of TNT.
Matt, you don't know what that means.
Jeez, I'm getting to it. Man, kids these days always just want the results of their math equations. Using the United Nations Explosions Consequence Analysis tool, yeah, that's a real thing, we can input our stats and learn that the micro bombs have a fatal zone of 4.35 meters or a little over 14 feet. Notice how close Mario and the gang are standing to that mini bomb? They dead, son! They dead! No question, they are within the 14-foot radius. Vibrations from that micro explosion would be felt over 80 meters away. That is over 263 feet away. That's the length of 9 school buses. And remember, this is still the smallest bomb to appear in the Mario franchise.
Oh, crap.
Oh, crap indeed, Internet. So if the tiniest bomb in the lineage is that deadly, how do the rest compare? Using the same methodology as before, we find that the original bomb from Super Mario Bros. 2 measures in at about 56% of Mario's height, which might not seem like that big of a difference, but think about those numbers. That is a bomb that is nearly 3 feet tall. A meter-tall iron ball loaded with explosive powder. 38 kilograms or 84 pounds of explosive powder, in fact. That translates to 113 megajoules of energy, 27 kilos of TNT. But what does that mean to Mario in this little bit of gameplay that we see on screen? Well, I'll tell ya, he dead, son. If he's within 23 feet or 7 meters of that explosion, he dead. Flat out dead. There ain't no coming back from that one. If he's not over 90 feet away from that explosion or the distance from home plate to first base on a baseball field, his eardrums would burst. And we're not even close to done because the boss Punchinello from Super Mario RPG has one last trick up his sleeve. The standalone biggest bomb in the entire franchise, his last-ditch effort to finish off Mario, the Mega Bomb.
Dun, dun, dun.
Like the little roll you got there going on. It's a sexy, dramatic reveal. This massive bomb is twice the height of Mario and comes loaded with, get this, an insane 1,000